Okay, so hello, good day. This is by group members Bayhon Eustaquio Piñon and Triñanes, and this will be an educational data structure showcase. So this will feature various types of data structures and explain what they are, what they do, and some of the operations that they can do. So without further ado, let's take a crack at it and let's begin. So let me first start by validating my main menu, the user validation if they enter the wrong choice or a choice that is not in the choices, which is the choices are A, B, C, D, and E. So let's begin by entering an integer, which is 5. So that's wrong. So let's see what happens if we press enter. It will correct the user. It will print out an error message, which is an invalid input. Please choose within the choices, so A to E. So let's say I didn't get that one again, so I entered G. So you can see it does the same thing again. It corrects the user and tells them what to do. So let's begin with linked list. So the linked list menu shows. So we will demonstrate the linked list part of the video at a later date at a later part of the video. But at this point, we will just be demonstrating the main menu. So if I press 3, it will take me back to the main menu. If I want to see stack data structure, it will show me the options for the stack data structure. So if I want to return, it'll let me return. If I want to see queue, let me press C, and it will put me to the queue data structure part. C again to return. Then the user validation still works because we're in a while loop, in which I will explain at the code part of this video. So let's move on to tree. And then there goes the tree. And that's it. And if I want to exit, I'll just press E. And please press enter to exit the program. Thank you. Yes. So that exits the program. So that is all for the main menu. On the next part of this video, I will explain the code behind the main menu program. Okay, so welcome to the code part of the main menu program. So as you can see, we have encapsulated it into one Python file in order to be handy and for easy submission and easy access. So, and this part is the tree data structure. This part demonstrates the trees. It is in one function, the classes, and then there are several nested functions in it in order for it to function. And then this goes the same for stack and all of the other data structures in our program. As you can see, linked list. There are several comments pointing what's going on with the code, um, telling them important information that will be relevant when you're reading the code and trying to edit or trying to manipulate it again. So as you can see, Q data structures is here. So let's move on straight to the main menu because it's just the same. So this is the block of code for the main menu. This is our main method. So as you can see, this is just prints out the options. This is our group members, which is not included in the loop because I wanted it to only appear during on startup, on boot. I didn't want it to show because it will be cluttered if it repeats and repeats and repeats again. So, and I don't think the group members' names are that important for the user to make a choice. So I just included it only on startup. So as you can see, I have here a list of strings, main choices. This will be the choices for our user validation. So the user can only enter A, B, C, D, and E, capital letters. So as you can see here, this is the user main in order for the while loop to go on with the loop, to activate the loop, because an empty string is not included in main choices. So automatically the loop initiates. So this is just the menu choices for what the user sees. It prints this out for the user choices. So this is the user main. We recall this variable in order for the user to actually make a choice while inside the loop. So this is just a declaration, a sort of declaration. And then as you can see, please enter your choice and then dot upper. As you can see here, this automatically makes the user's input as an uppercase character. So, so automatically, if they enter a lowercase a, it will be converted into an uppercase a automatically. So as you can see, it's pretty straightforward. And as you can see here, that it just calls the functions that I mentioned earlier, the linked list DS, which is a, so linked list data structure a, and then else, if the user main answer is b, is the stack, as you can see, and so on and so forth. The latter part of this if statements, the one inside, it just resets the user main, which is um, calls it again in order to reset the variable, and then continue in order for the loop to go again, in order for the user to make another choice or to make another iteration. And then here is E, which will make our program quit once the user presses enter, because it reads the enter key only because it is an input. While else if this line of this couple of lines of codes, it just it will just print out this error message in order to correct the user and tell them what to do. So that's basically it for the main menu. Stay tuned for the next part of this video where another data structure and another block of code will be explained. So thanks for listening.
Now, to start the program, we'll start with single linked list. So we can append to list. If we're gonna call one, display. Technically, it just calls the append function. So if there's no existing node, it's gonna create a new node. Else, it's just gonna add at the end of the list. Say if you wanna add 3, the display is just gonna append at the end of the list. You can also add at the start of the list. It's gonna call add start function. Say 1. And then we have 3 existing node. To delete a node, you just have to enter its position to delete. Say if you wanna delete the first node, if you wanna delete this middle node, which is 2, you can delete 2. 2 is gone. You can delete the first node and the last node. Last and first node. You can see that the list is null. That's it for singly linked list. Similarly for doubly linked list, if we're gonna append the list, it's gonna create a new node if there's no existing node. Say 2. 3. We can also add as the start of the list. And for deleting, there's 3 cases. So if we want to delete the last node, it's gonna call the delete function and then delete its last node. And we can also delete the first node, which has an adjacent node, which is 2. So it's gonna call this part of the function, and we can delete the first node, the first and only node. The list is empty. That's it. Now, for the actual code itself, we have a class for the node. This is used when we want to create a new node and add it to the list. Now for single linked list, we just set the head to none. Then for append, for adding node to list, there are 2 cases. So first, it's gonna create a new node and then if there is no existing node in the list, then it's gonna create a new node for that list, else it's just gonna add at the end of the list. For displaying, it's gonna traverse the list and at the same time printing its data value. For the empty function, it's gonna return a boolean variable if the list is empty or not. And for the add start function, it's gonna add a node at the start of the list. Say it's gonna create a new node and then set the new node to the first node and then set the head pointer to that first node. For the length, it's gonna return an integer value of the length of the list. For deletion, there's two cases for this. First, we create a current pointer for traversing the list. Now, if we want to delete the first node, it's just gonna set the head to the next node of that and then set the first node to none, which means it's just deleting the first node. And if you wanna delete a node in the middle or at the end of the list, it's gonna traverse to that point of deletion and then just sets it that node next to the next node of deletion and then just delete the node of we want to delete. And if it's out of range, it's gonna print that error that the position we want to delete is out of range. For doubly linked list, it is similar to the singly linked list, except that there is one extra pointer we will use, which is the prev for the node. So if you wanna append, if there's no existing list, as I've said earlier, it's gonna create, else it's just gonna add at the end of the list. For the add start function, we create a new node. If there's no list, it's gonna create a new one, else it's gonna change the first node to the new node. So it's just gonna add at the start of the list. It's actually similar to singly linked list. Now for deletion, it's actually kinda complicated for this part. And there's actually many cases for this. First, you create a current pointer to progressively traverse the list. And if we want to delete the first node, we have to check if it's the only node in the list. If that's the case, we just delete it, simply delete it. Else, if it's not the only node in the list, then we create a new temp pointer to the next node of deletion and then just delete the first node and set temp previous pointer field to none and set the new head to that new node, the next node. And then if you want to delete somewhere in the middle of the list, first it's gonna traverse the list. Then if you reach that point of traversal, point of deletion, and then we create two new pointer variable which holds the current node to be deleted next and its previous node. So the current node to be deleted, we're gonna set its adjacent nodes, the previous and next, to point at each other, and then we just clear the node we want to delete. And lastly, if you wanna delete the last node, we'll just create a new previous pointer that holds the previous pointer of the one we want to delete and just delete the last node, and then at the same time sets the new existing last node to point to none. Uh, None. It should not be here. Right, I guess that's it. Now for the length, it's similar to the singly linked list and the displaying. Now for the main class, it's just gonna print the menu and lets the user pick what they want. So for singly linked list, the user wants to add, it's gonna call the append function. If the user wants to add at start, it's gonna call the add start function. Similarly to doubly linked list, it's the same, except that it's creating a doubly linked list, and that's it.
Hi guys, Miss Julius from my Piñon. So ito po yung ginawa kong program which is stack. So pinapakita dito kung ano ba yung stack and how to use it. So try mo natin run yung program bago natin ipaliwanag yung paano ba siya ginawa. Okay, so first if we try to press 1, then lalabas dito yung example ng stack as you can see here. So step by step siya guys para mas maintindihan ng user kung ano ba talaga yung stack. So first step, we'll create a stack and insert the following elements. Ayan, dito niya kung paano kinrate yung stack. Then press and continue. There we go. Para makapag-insert tayo na elements, we will use append function. As you see here. Ito yung mga syntax para magamit siya. Then we will print it, press any key to see the result. So para lumabas yung result, press na tayo na enter. Then actually, as you can see here, lumabas dito yung initial stack, which is A, B, C. After that, press any key to continue. Then, ang gagawin naman natin ay magpa-pop tayo. We'll be using pop function to pop the element from the stack. Element pop from the stack, CPA. So, ganyan lang siya mag-pop. Then, after that, press any key and to see the entire result. Ayan, there we go. Ito yung resulta niya. Initial stack, elements pop from the stack, stack after elements are pop, and press any key to go back to the main menu. Next naman natin is stack definition. So, if you press 2, dapat lalabas yung definition ng stack. So, you see here, this is the definition of stack. It is a linear data structure that stores item in last in, first out, or first in, last out manner. Nakalagay na dito kung saan natin kinuha ito. Then after that, if you press any key, we should be able to go back to the main menu. Then if you press 3, it should end the entire program. As you can see here, the program has stopped. So for validation natin, kunyari magkamali ka ng pindot, kunyari X, halabas dito wrong input. Then kapag within values naman siya, like, pero hindi siya, wala siya sa if statement, kunyari 4, not in the choices ang lalabas. So there we go. That's the entire program itself. Then we're gonna exit and show you how the program works. So first we will use these imports in order to run the program. Next we will use the function here. We will name it stack1. Then we'll name it stack. Then in order to append it, we'll just need to use this syntax stack.append. Then we'll put the value A, B, C. Then after that, we will print it and print the stack. Next up, in order to pop, then first you just need to use print stack.pop. Then it should delete it one by one. And after that, we will print it. Next is I created a depth function here, which is menu. This is the menu that you have seen earlier. Then I use try and accept function so that if any input goes wrong, it should have a response here like this. Oh no. Then after that, we have some print here. This is the menu, and this is the variable data type int. Then we use an if statement. If response tab is equal to 1, then this print statement should come out and input. If it presses any key, it should go to the next set of lines here. Then it just keeps on going. This is how I use this stack. There we go until we reach result here. Press any key to go back to the menu. And I also put a while so that it just keeps on going. So it has a loop. Then if response tab is equal to 2, then definition of stack should come out as a print. Then if you press any key, it should read here that you press any key. And it should go back to the menu. After that, if response is equal to 3, then it should exit the entire program. I use exit function here. Then if you input within the choices but it doesn't have a if statement on it, it should pop not in the choices. And here is just a except failure in try and except. So if you put a character, this should pops up. Then after this, I call the menu function outside the def so that it will work. So that's going to be the program itself. Thank you for watching and take care.
Hey, so hello, good day. I will be discussing the queue data structure part of our machine problem in data structures. So to sum up this program in words, this program shows what operations are possible on a queue data structure and what is the definition of a queue data structure. And this educational program shows the user what are the operations possible, what can happen, how it works, how it is used. It's basically a showcase of what the queue data structure is. So get a crack at it, and then let's begin. So my name is Paul Triñanes. I made this program for our machine problem in our data structures lab class. Okay, so let's begin. So let me begin by demonstrating my user validation in this program. So the first menu is the queue data structure menu. So the only choices available are uppercase A and uppercase B. We'll talk about uppercase. We'll test the uppercase sensitive part of the user validation later, but let's begin with inputting D. D is not included in the choices, so there's A and there's B, no D. So let's test it. So it corrects the user. It tells them what's wrong. Invalid input, user input must be in the choices, so please try again. It gives them the chance to try again. So what if I made a mistake again? I input 5. Maybe I'm dyslexic or something, but we will demonstrate. The user input must be in the choices and please try it. So let's move on. So let me first input a lowercase a. Let's try it. Let's see what happens. So as you can see, it shows what the definition of a queue is. This information based on the Geeks for Geeks website. It's a great website on information on various data structures and all things linked in programming wise. So I suggest you check it out, but let's move on. So if I enter an uppercase A again, as long as it's an A, it'll do the same thing. I will explain that in a later part of the video on the code part. But for now, let's just say it works. Okay, so it's the same with B, uppercase, lowercase, doesn't matter. So let's try the user validation again for fun. Doesn't work, so let's move on. So invalid input, because we entered G and the choices are A and B. So let's unpick B. There. It shows the operations on data structure. So without further ado, let's move on to the one operations in Q, which is an operations option in this submenu. Let's open one. There. It shows the 5 operations of Q that are used in this program. They are listed as follows or below. On Q, DQ initialize is full and is empty. The last two, the latter part, the last two option, the last two labels basically speak for themselves. So is full, it checks if the queue is full. For example, if I set the max size to 5, then if the number of elements inside the queue is 5, so therefore is full will become a Boolean value of true. So if it's not 5 over 5, 5 elements and with the 5 max values, let's say it's 4 and the number of elements is 4 and the max value is 5. So is full it will become the Boolean value of false, 0 in binary. Okay, so it's the same with is empty. It is the opposite of is full. So if it is empty, if it, let's say the max value is 5 and then the number of the elements is 0, so is empty will become a Boolean value of true. Yes, and then if it has at least one or more elements, 1 over 5, 1 over max of 5, 2 over max of 5, 3 over max of 5, it will show false because the queue is not empty. So moving on, so dequeuing is basically deleting an element from the front of the queue or the top of the queue because dequeue is the same as deleting because that's how a queue works. The unqueue is inserting at the end of the queue. Basically speaks for itself. Okay, so let's move on. After being done with the operations possible in queue, let's begin in initializing the queue, which is creating an empty queue. Again, so you have chosen to initialize a queue, so please enter the size number of elements of the queue. So if they we added this feature because if they put 99999, the program will go into an infinite loop. So to prevent that, and for the sake of just demoing the capabilities of Q, we just limited it to 30. For the sake of this demonstration, we will enter 5. 5, Q successfully installed with the size of 5. So let's move on to show elements of the queue. So the elements of the queue currently is 0 out of 5, which is 5 is the maximum. And then you see those braces there, that's the queue. There are no elements yet. So let's try adding one now. So 4. So array representation. So that shows the current queue. So we have a reference on what to add or what we need to insert. So I'll add my name. So my name is Daniel. Currently in list Cameo. So I will try to fill this up, fill it up to 5 until its max value. So 4. Gap. Gap is my nickname. 4. And 18. Let's put Paul. Paul's my second name. Getting close. So let's try Meow. And lastly, yep. No. Can I let's just add a random name? So Sean. So if we try to add again, add elements to queue, say the current queue is full, so please dequeue or empty the queue, which we will demonstrate now. So pop elements from the queue, which is dequeue or delete. 5. So you can see we have removed, we have successfully dequeued the queue. So we can see Gamiel is now gone because he's the first one in, so he will be the first one out. We can just keep repeating pop. So it's empty again. See, it's empty again. So let's try popping. So the current queue is empty, so please unqueue and add elements to the queue. So that sums it up. So if we exit, we'll exit the program, and then we'll move on to the code part of our video. Stay tuned. Okay, so welcome to the latter part of our video, which is the code for my submenu of the Q data structure in our educational data structure showcase. So let's begin. So some of the details are already commented out, so it can explain itself, but for this purpose, a video is required for further demonstration and further explanation of the features. So this is what I'm doing today. So again, this is Paul Triñanes, the maker of the main menu and the Q data structure submenu. So moving on, so form Q, import Q. So we just replaced it with a capital Q in order to import the Q. So importing Q is needed in order to access the built-in method for queues because Python has a built-in method for queues. So I took advantage of that, in which I explained it before in the previous video on how it works and what happens with it. So as you can see, we have here the list of choice. This is for user validation. So the user has only two options in order to progress, in order to not throw an error, for the program to not throw an error. So this is our user input. This is our main menu for the Q data structure submenu. So while user is not in choice, not in here, so it will keep repeating the loop until they enter something from here. So this is the menu, this is the options. So this is if user A, which is what is Q data structure, this is this one. This is the explanation from Geeks, and then user str continue. Continue just repeats the loop, keeps the loops going. So yes. So I would also like to point out that upper is used because if they use a lowercase, it is still considered a. So the lowercase a is still an A. So I assume that if the user entered the lowercase a, they still meant A. So I've added that feature for the user. So elif user B, which is the operations part of the program. So elif B, so it uses the same process for user validation. So in B, these are the choices, and then the checker. This will be referenced later. The checker checks if the stack exists. Oh, the queue exists rather. So this is show B. Show B is just our menu, our submenu, which we demonstrated earlier. This shows what options are available for the user. So print show B. Show B is this string, the menu, show B. And then bus B user, sorry, B user is the input of the who will use this program. So it will based on B choice. So while bus B user is not in B choice, so it will throw this string. It will print the string and then repeat again until again and again and again, as long as the user input is not in B choice. So that's my user validation. So if one, this is the information part of the submenu, which is the operation submenu. It explains very briefly the operations available in Q and the ones that will be demonstrated in this program. So after printing all of these, it will give again, it will give the option to the user to move on to another choice, and then it will print show B user, so show be there. So moving on. So LFB user 2, this just initializes the queue. So checker variable checks yes. So this is the part where the checker variable changes. It becomes from 0 to a 1. So yes, we already have a current queue because we can initialize once we already initialized in the past in this program. So elif checker is 0, so that means there is no queue yet. So we can move on and initialize. So this is the process of initialize. We used max is numeric. Um, in order to user validate if it is really a number, and then we added an or, which is if one is true, it will demonstrate, it will continue with the loop. So one is true here, it will put invalid input and then repeat, ask the user again. Thus user validation. So next part is queue max size int max. This is the main part of the initialization. This Python queue has already a queue module. So this just initializes it, that this particular line of code initializes it. So this is a success message saying that they have made an empty queue with a max value. Max is the max value we asked the user earlier on what we want our max value to be. So checker becomes one. Observe here. So if checker becomes one, it means there's already a queue. The queue is already initialized, rather. So print this is the same to continue the loop, to give the user a chance to open others. So lf user of tree, if checker 0, this means there's no queue yet. So it prints out queue does not exist yet, please initialize queue. Yes, without the queue. So it directs the user to enter to 2. Enter 2 again. Again, the same process for the loop, rather. And then this option 3 shows what the queue contains. So for your representation, it was demonstrated before. So it converts the queue into a list to be printable, because if you just type this line of code in print, it just shows the memory address of the module. So that won't work. So we want to show the list of what is in the queue. So list converts it into a list and then prints it. So show B again, opens again, and then this is the same code for 4, which is unqueuing. As you can see here, unqueuing is the process of adding elements to the queue. Moving on, again, there's checker. Checker is equals to 0. So we have to initialize first, because we can unqueue if there isn't a queue at all. So yes, so we have to initialize. We repeat the looping, continue the looping rather. So elif checker is 1 if the queue exists, so we can move on. Because there's a queue, we can unqueue to a list. So the same, these are just prints the values literally. And then the put function, yes, written here, and the queue and should the Python queue module enqueues the specified variable inside the parentheses. So unqueue, we ask the user for unqueue. So it's in the format of string. So you can input a number, a symbol, a decimal, a double value, whatever, as long as it can be put in a string. It can put it in the queue. So this will be our success message, signifying that it has been successfully entered in this queue. So on enqueue, which is here, will be displayed. So it has an user validation. So the user can see that, oh yes, it has inserted, which is a good thing. And then here we list it again in order for the user to see what the current queue is with the new value or the new element inserted. So again, print show B. This will be just continuing the loop. And then else if demo queue is full, demo queue is our queue. If it's full, we will repeat the loop again, and we will ask the user to please dequeue or empty the queue to free up space in the queue for new elements. That's correct. Okay, so moving on, dequeue, this is just the opposite of onqueue. So same checker element, checks if there is queue existing, does not exist, that's the user again, yada yada. So else if checker is 1, queue exists, and it is not empty, because if it is empty, it will throw an error if we try to dequeue. So it should be not empty. So empty is equals to false. You can see here we show the before the deletion, the dequeuing, what is in the queue, and then this line of code demo queue.get is what will dequeue our queue, and then Next part, we will show what the queue is after the deletion rather, excuse me. And then moving on, so it will repeat the loop. Then if it is empty, true, the current queue is empty, please unqueue and add elements to the queue. So it will repeat the loop and then ask the user to add elements. So it will not move on to the D queue because that will throw an error if it is empty. LF6 quits the program. Then LF B user not in B choice, this is here, will throw an error and then repeat the loop. And then if user not in choice, it is for user validation again. So that concludes my program for the Q7. So thanks for listening.
Good day, ma'am. Ako po si Inigo Ivan B. Bayhon. Ang program po namin ay tungkol sa isang educational system na mag-i-inform po sa mga user namin na the different kinds of and types of data structures. So, yung type ng data structure ko po is sa tree. So, irarun ko po yung program. So, ang first na lalabas is isang menu. 3 data structures menu. And may 4 options yung user. 3 definition, binary search tree, AVL tree, and exit program. Now, to enter your choice, 3 definition. May lumabas po na definition about trees. A tree is a nonlinear data structure compared to arrays, linked lists, stacks, and queues, which are linear data structures. A tree can be empty with no nodes, or a tree is a structure consisting of one node called the root and 0 or 1 or more subtrees. And after that po, nag-loop po ulit yung program pabalik sa main menu para makapili po ulit yung user. Next is the binary search tree. So, ang lumabas po is definition ng BST. Binary search tree BST is a binary tree extension with several optional restrictions. The left child value of a node should in BST be less than or equal to the parent value, and the right child value should always be greater than or equal to the parent's value. So, ito naglabas po yung program ng sample na isang BST. Ang elements ay 7, 5, 15, 3, 6, 9, and 20. So, ang nakikita po ng user ngayon is 4 options sa submenu para sa BST traversal menu. First is pre-order, next in order, and the last one is post-order. And we will try the pre-order. 7, 5, 3, 6, 15, 9, and 20. For the in order, 3, 5, 6, 7, 9, 15, and 20. Next, for the post order, 3, 6, 5, 9, 20, 15, and 7. And the user after that has the option to return to the menu. Next is the AVL tree. An AVL tree is a binary search tree, self-balancing. On behalf of the inventors, Adelson Welshi and Landis, the name AVL is given. This was the first tree that balanced dynamically. A balancing factor is allocated for each node in the AVL tree based on whether the tree is balanced or not. The height of the node kids is at most 1 AVL vine. Next, the program has shown an AVL tree sample output. The elements are 34, 24, 45, 15, 27, and 57. It also has given the user the height of the tree, which is 3, because there are 2 levels and the other one is the root. Next, there is another submenu, but now it is for the AVL traversal menu. It has the same options, pre-order, in-order, post-order, and to return to the menu. For the pre-order, 34, 24, 15, 27, 45, and 57. Next for the in order. 15, 24, 27, 34, 45, 57. Next for the post order. 15, 27, 24, 57, 45, and 34. Next, return to the menu. That is it for the options for the exit program. Ngayon naman po ma'am, i-testing po natin yung mga validation. Now, yung options lang po na valid dito is 1, 2, 3, and 4. Kunyari po, naglagay po user ng F. Lalabas po wrong input. Next, sa tree definition, wala naman pong input, kaya walang validation. Next is for the submenu of the BST. Kunyari nagkamali po user na nalagay T. Lalabas po invalid input and maglo-loop po ulit. And may choice pa rin po user na mamili sa submenu. Next is the AVL3. Nagkamali po ulit yung user. Ay invalid input. Nag-loop din po ulit dito para may choice pa rin yung user to retry. And for this one, the same thing, wrong input. Ngayon lang po ma'am. Next, i-explain ko po yung sa codes. First is the def init for the self-right, self-left, self-right, and the self-value. Next is the def, the method for description. It is desc, and this is the one that is in the option 1. Yung mga next po is yung para sa traversal. In order, post order, pre-order. And yung order po nito is left, root, and then right. See, dito po is left, right, root. Dito po is root, left, then right. Next, for the method for the BST. The program has showed the user the meaning of the BST, and this is the one that was showed earlier. Ito po yung sample na BST na tree. Ito may yung code para sa mga nodes. Ayan po 7, 5, 15, 3, 6, 20, and 9. Next is for the submenu. Naglagay po ng while loop para po pag sa try except sa validation, para pag nag-error po is mag-loop po ulit and makakapagpili pa rin po yung user. Next is for the AVL. Class 3 node is for the one at the very top. Dito po self-val for value, self-left, self.right, and this one may height po dito kasi po ay AVL3 and may balancing po. Next is for the insert. Ito po. Para sa root.left and yung isa sa root.right. Ito po, root.height is equal to 1 plus max kasi po kada insert po ng isang value, nagbabalancing po yung 3. Next is for the def, for the rotation, if may imbalance po. Ito po yung sa left rotate and the right rotate. Z.height, Z and Y po yung ginamit na variables para po sa pagkuha ng height. Z and Y. Dito po same lang din po. Dito po is for the get height, get balance. Para po sa height. Dito po is para po sa pag-balancing ng tree. Dito po is yung parang sa dito po, which is yung traversal. Dito po yung pre-order, post-order, and in-order. Same idea lang din po. This is the root, left, right for the pre-order. Sa post-order ay left, right, then root. Sa in-order ay left, root, then right. Next for the AVL, the method. Naglabas din po ng definition. Next, ito po yung sa code para sa roots. Is 15, 24, 34, 45, 57, and 27. Next is for the submenu. Ganun lang din po while nag-loop para po sa validation sa try except para sa valid input. And ito po yung last na method sa main menu. Ito po yung sa 3 data structures menu. Nag-while loop lang din po, and then nag-while loop po para po sa validation din pag nag-wrong input, and para mag-loop ulit para may choice pa rin yung user. That's all, ma'am. Thank you.